In this video, I'd like to talk about the math question of the day for Wednesday, April 19th, 2023. And with this problem, we need to determine whether each pair of lines are parallel, perpendicular, or neither. And to answer a question like this, you will need the skills of Algebra 1, or you may see this in a geometry class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start going through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. Now, when looking at two different lines and determining if they are parallel or perpendicular, we are primarily focused on the slope of each line. Since remember that if we have some line and we graph it, it has some steepness to it, some slope. And usually we can write out lines like they are written here in what's called slope-intercept form. And that's generally seen as y is equal to mx plus b, where m, the coefficient on x, that's the slope of the line, or the steepness of the line, and b, that is the y-intercept. That's where the line crosses this y-axis, and that's when the x value is 0. And you can see that makes sense because if you plug in 0 here, this term goes away and y is equal to whatever b is. And when looking at, let's say, parallel lines, if I draw on a line that's parallel to this, and these aren't drawn perfectly, but parallel lines have the same slope. So we can mark that down, that in order for two lines to be parallel, they have the same slope. But a perpendicular line is a little bit more complicated. Essentially, if we have two lines that are perpendicular, they would cross at a right angle. And let's say for this line going upwards as we move to the right, it has slope m1. And let's say this second line that crosses it at a right angle has slope m2. The product of these two slopes, m1 multiplied by m2, if the two lines are perpendicular, this product is always equal to -1. And I won't prove this in this video, but it is definitely true. And another way to look at it, if we rephrase the equation, we could say that one slope is the opposite reciprocal of the other slope. So let's look at an example. Let's say for two perpendicular lines, we have m1 is equal to 3. Then for these to be perpendicular, we would flip this fraction. You could put any whole number over 1. We could flip the fraction and then make it negative. And that would guarantee that these two lines, the slopes of these lines, show that they will meet at a right angle. These lines are perpendicular. So when comparing these two given lines, line R and line S, we're mostly focused on the slope. And remember, when looking at this slope-intercept form, the m value, the coefficient on x, tells us what the slope is. So right here, the coefficient on x is -5, and right here, it's positive 1/5. So we know they're not parallel because in order to be parallel, they would have to be the exact same number. But they could be perpendicular. In fact, that's what they are, because if we take one of them and flip it and then make it negative, it's equal to the other one. So let's start with -5. We can call that our m1. And notice that if we put it over 1, we flip it over and change the sign to the opposite sign, we would get 1/5, which notice is the exact value from line S for the slope of that line. So because these slopes are negative reciprocals of each other, we can conclude that they are perpendicular to each other. And one other way to check is to use this property here, that their product should equal -1. And if we take, let's do it down here, minus 5 multiplied by positive 1/5, we can put it over 1, and we're multiplying fractions, so we'll just go straight across. We get minus 5 in the numerator and positive 5 in the denominator, and this would, of course, simplify to negative 1. So that's another way to check that the two lines are perpendicular. And I should mention, most lines would fall into this category. These are both very specific cases, but most lines will cross but won't be at a 90-degree angle. They might be at something either bigger or less than that, depending if you're looking at the obtuse angle or the acute angle here.